Welcome back, everyone. Today we're going deep with one of the most influential scientific minds ever, Michael Faraday.
I'm excited for this one.
Yeah, this is a good one. To help us unravel Faraday's brilliance, we've got excerpts from two fantastic biographies, Michael Faraday, Physics and Faith, and Michael Faraday and the Electromagnetic Field.
These sources give us a great look, not just at his groundbreaking discoveries, but also his personal life, his faith, the whole picture.
Right. A real deep dive. So get ready for some serious aha moments as we trace his journey from, well, pretty humble beginnings to becoming this scientific superstar.
And, his story is really inspiring. It shows how passion and hard work, plus maybe a little bit of luck, can completely change the course of life.
Right, a little luck never hurts. Okay, so picture this. The rugged north of England. That's where the Faraday family had their roots. We're talking Mallerstang Fells, Wild Boar Fell.
Yeah, tough, isolated landscape, hard work, and a connection to nature were basically ingrained in you from childhood.
And those values really come through in Faraday's character, right?
Oh, absolutely. They were essential.
And we can't forget his family's strong Sandemanian faith. This small Christian sect played a huge role in shaping his worldview, didn't it?
A huge role. It was a constant thread throughout his life, even as he became a world-renowned scientist.
Okay, so we've got this backdrop of hard work, nature, and faith. But Michael's father was a blacksmith. The family wasn't well off, so Michael's formal education was pretty basic.
Right, basic, but his thirst for knowledge, that was immense. It's fascinating. He basically became a self-made intellectual, devouring books, attending lectures. He even started doing his own experiments.
Wow, a true DIY scientist before it was even a thing.
Yeah, way ahead of his time.
He was clearly driven, but he needed a break, right? That lucky chance to really launch his scientific career.
And that break came in the form of Humphrey Davy, a superstar chemist at the Royal Institution in London. Faraday was captivated by Davy's lectures.
Can you imagine being in that audience just soaking it all in?
Well, he did even more than soak it in. He actually bound his meticulous lecture notes, we're talking 386 pages, and sent them to Davy.
Bold move.
Bold and brilliant. Davy was so impressed that he eventually offered Faraday a job at the Royal Institution.
So talk about a lucky break. He suddenly finds himself right at the heart of the scientific world.
Exactly. It wasn't a glamorous start, mind you.
Right, humble beginnings.
But for Faraday, it was an incredible opportunity. The Royal Institution was a hub of scientific activity, public engagement, everything.
So it wasn't just a job, it was a launching pad.
Exactly. And that's where his career really took off. He starts experimenting, collaborating, and eventually he becomes a brilliant lecturer himself.
Okay, but his relationship with Davy wasn't all smooth sailing, was it? It seems like it was pretty complex.
You're right. There was mentorship, for sure, but also rivalry. Davy nurtured Faraday's talent, but as his protege's brilliance grew, well, Davy felt threatened.
Almost like a classic case of the mentor being overshadowed by the student.
Yeah, you could say that. There were even accusations of plagiarism flying around. But you couldn't deny Faraday's genius. He was truly a force to be reckoned with.
Okay, so let's dive into some of Faraday's early work in chemistry. What was the scientific landscape like back then?
It was the early 1800s, and chemistry was undergoing this huge revolution. New elements were being discovered left and right. Atomic theory was taking shape.
It sounds like a really exciting time to be a chemist.
It was. And Faraday jumped right in. He started with meticulously analyzing all sorts of substances. Clays, metal alloys, even whale oil.
Whale oil, like the stuff they use for lamps?
The very same. All this groundwork was actually crucial for his later breakthroughs.
So he's honing his skills, becoming a master of the lab.
Exactly. But he wasn't just a lab rat. He took his knowledge and applied it to practical problems. Like this one time, he served as an expert witness in a court case about a sugar refinery fire.
Wow, that's pretty interesting.
Yeah, the insurance companies didn't want to pay, claimed the refinery hadn't reported a fire hazard. But Faraday, through his experiments, he proved that the oil they were using could ignite at much lower temperatures than anyone thought.
So even early on, we see this commitment to scientific rigor, to using his knowledge to address real-world issues.
Right, a theme that runs throughout his whole career. He had this incredible curiosity about the natural world, but also this desire to use science to benefit society.
And all this was before his groundbreaking work on electricity and magnetism. Right?
Oh yeah, way before. But all that chemical research, it actually laid a surprising foundation for those later discoveries. For example, in 1823, he accidentally liquefied chlorine gas.
Ah, science and serendipity.
You got it. And this led him to liquefy all sorts of other gases, which helped reveal some fundamental principles about how gases behave.
So even seemingly unrelated experiments can be these important stepping stones.
Totally. It shows that even the most famous scientists start with the basics, meticulously building their knowledge.
And let's not forget about this whole dynamic with Davy. That tension must have been tough to navigate.
Oh, it definitely was.
Hmm.
Davy championed Faraday initially, but as Faraday's star rose, their relationship really became strained. There were attempts to, hinder Faraday's career, and their rift, well, it never fully healed.
It's a shame, but I guess it reminds us that even brilliant minds can get caught up in personal conflicts.
It happens. But despite all that, Faraday kept going. He was driven by this passion for discovery, this deep belief in his own abilities.
And that leads us to one of his most famous discoveries, I think. Benzene. How did that happen?
So picture this. 1825. He's analyzing this liquid byproduct from, believe it or not, whale oil gas production.
Whale oil again.
Yeah, it pops up everywhere with Faraday. Anyway, he isolates this substance that forms these beautiful white crystals. Turns out it's benzene, a fundamental building block in organic chemistry.
So from whale oil to a groundbreaking discovery, what makes benzene so important?
Think of it like a foundational molecule. It's the basis for countless chemicals we use every single day. Plastics, dyes, pharmaceuticals, you name it.
Wow. I had no idea whale oil could have such a ripple effect.
It's amazing, right? It's the perfect example of how basic research, driven by pure curiosity, can lead to these unexpected, far-reaching practical applications.
But it wasn't just about the molecule itself. Faraday's work on benzene also showcased what an incredible experimentalist he was.
Absolutely. To isolate benzene, he needed a deep understanding of chemical processes, but also incredible precision. This meticulousness, it would be crucial in his later work with electricity and magnetism. But before we get to that, there's another side of Faraday we need to explore: the communicator. He was incredibly passionate about sharing science with everyone.
A true pioneer of science communication. And it all really comes through in his work at the Royal Institution. He started those Friday evening discourses, right? And the Christmas lectures. They're both still running today.
Incredible, isn't it?
It is. So what made his approach to these public lectures so special?
Well, he had this amazing gift, this ability to take really complex ideas and make them easy to grasp. He'd use these engaging demonstrations, really clear explanations, and he always emphasized the practical applications of science. He wanted to show people how science connected to their everyday lives.
It wasn't just lecturing at people. It was about sparking their curiosity, making them see the wonder of scientific discovery.
Exactly. He really believed that science shouldn't be locked away in these, ivory towers. It should be shared and celebrated by everyone.
And he was kind of a showman too, wasn't he? I read about some of his demonstrations throwing things at a giant magnet.
Oh, yeah. That one is legendary.
Right.
Or the time he stepped into an electrified cage, to show how electrostatic shielding works. And these weren't just gimmicks. They were carefully designed to bring these really complex concepts to life.
But it wasn't just about entertainment. There was a deeper purpose behind all of it.
Right, absolutely. His lecturing style was actually really influenced by his Sandemanian beliefs.
What?
Oh, yeah. He believed in logic, evidence-based reasoning, and in letting people draw their own conclusions. For him, science was a way to reveal the wonders of God's creation.
That's such a fascinating connection. So his scientific work and his faith were really intertwined.
Completely. And you see this reflected in both his lectures and his research. He was always meticulous, methodical, always searching for truth, both in the lab and in his spiritual life.
And this brings us, I guess, to his work on electricity and magnetism, this work that completely revolutionized our understanding of these, well, pretty fundamental forces.
It really did. And it's amazing to think that he had already made all these significant discoveries in chemistry and was already a renowned lecturer, all before he even tackled this new frontier.
Yeah, talk about boundless curiosity.
Seriously. He wasn't content to rest on his laurels. He was always searching for new challenges, a deeper understanding.
Always pushing the boundaries. So when Faraday began exploring electricity and magnetism, it was the early 1800s, right? And it was a time of intense interest in these topics, but still so much was unknown.
Yeah, scientists were just starting to grasp the connection between electricity and magnetism.
There was that pivotal experiment in 1820 by Hans Christian Ørsted. You know, the one where the compass needle deflects near a live wire?
Exactly. That was a total game changer. It was the first clear evidence that electricity and magnetism were linked. And it sparked a wave of research all across Europe.
And Faraday was right in the thick of it. What were some of his early contributions to this new field of electromagnetism?
Well, interestingly, he wasn't initially convinced by this idea from William Wollaston that an electrified wire should rotate near a magnet.
Oh, really?
Yeah, Faraday actually thought it would move side to side, not rotate.
Huh. So he was challenging the accepted theory based on his own understanding of how these forces worked.
Exactly. And he proved his point with these ingenious experiments. In 1821, he designed this setup with a wire dipped in mercury connected to a battery. When he brought a magnet near, the wire moved, just as he predicted, toward or away from the magnet, depending on which pole he used.
So simple, but so brilliant.
Right. It speaks to his genius for understanding these really fundamental principles and figuring out how to design experiments to reveal them.
And this led to his creation of the first electric motor, didn't it?
You got it. That experiment with the moving wire, that was the foundation. He later refined his setup, bending the wire into this crank shape. And when he brought a magnet close, the crank would spin, trying to get as near to the magnet as possible. And by flipping the magnet's poles, he could keep that crank rotating continuously.
So he basically built the first device that could convert electrical energy into continuous motion.
Exactly. And this was the basis for the electric motors that power so much of our modern world.
But sadly, this is where their rivalry with Davy really casts a shadow, doesn't it?
Yeah, it does. Davy accused Faraday of stealing his ideas about electromagnetic rotation. And this tension, well, along with other things, it caused this big rift between them.
It's a shame that such a promising partnership ended on such a sour note.
It really is. But even with all this drama going on, Faraday just kept working, driven by his passion and this deep, deep belief in himself.
And that leads us to, I think, his other really revolutionary breakthrough, electromagnetic induction.
Right, 1831,
Oh.
a real turning point. So Faraday had this hunch that if electricity could create magnetism, then maybe, just maybe, magnetism could create electricity too.
A kind of reciprocal relationship between these forces.
Exactly. And to test this theory, he designed this brilliant, elegant experiment. He coiled two separate wires around an iron ring. One wire was connected to a battery, the other to a device that could detect electrical current. And when he switched the battery on and off, he was creating this changing magnetic field in the ring, right? And he saw a brief pulse of current in the second wire. He'd done it, electromagnetic induction.
And this is the discovery that underpins so many technologies we rely on today, from power generators to transformers.
Absolutely. It was a pivotal moment. It changed our understanding of electricity and magnetism forever and paved the way for the electrification of, well, everything.
But Faraday wasn't done. He was always pushing forward, always wanting to go deeper.
He was. And that drive led him to another incredible invention, the dynamo. This was a device that could generate a continuous flow of electricity by spinning a copper disc between the poles of a magnet.
So the first practical electrical generator.
Exactly. And it was based on those principles of electromagnetic induction he just discovered a few months earlier. Yeah. The pace of his work was just incredible.
It really is mind-blowing how quickly he turned these fundamental discoveries into working devices.
I know. It just highlights his remarkable intuition and his ability to see the practical potential of his research.
It wasn't all about science, though, was it? His personal life was evolving, too, during this time.
Oh, yeah, for sure. In 1821, he married Sarah Barnard, a fellow Sandemanian. And it was, by all accounts, a very happy and supportive marriage that lasted over 45 years.
So he had this strong foundation of faith and family to ground him as he navigated the, let's be honest, often challenging world of scientific research.
Absolutely. His religious beliefs and his personal relationships were a constant source of strength and inspiration.
So let's dive a little deeper into his later work with electromagnetism. He developed some really interesting ideas about things like lines of force and the concept of a magnetic field.
Right. These were key to moving beyond this, purely mechanical view of these forces. Faraday started thinking in terms of fields of energy that permeate space.
So it wasn't just about the objects themselves, but these invisible forces acting between them.
Exactly. He pictured these forces as these lines extending from magnets and electric charges.
Kind of like those diagrams you see with iron filings aligning around a magnet.
Exactly. Those really help you visualize those invisible fields. And Faraday believed that these fields were absolutely fundamental to understanding electricity and magnetism.
And he documented everything so meticulously, right? He had those commonplace books where he'd record all his observations and ideas.
Oh yeah, those notebooks are amazing. They're like a window into his thought process. You can see how his ideas evolved, how he wrestled with these complex concepts, how he designed his experiment.
Like peeking into the mind of a scientific genius.
It really is. And in those notebooks, you also see how his scientific thinking was influenced by his religious beliefs. He saw the order and beauty of the natural world as evidence of God's design.
So for him, science was a way to explore and understand the wonders of creation.
Exactly. And his faith provided this framework for comprehending the really profound implications of his discoveries.
But he never lost sight of the practical side of things, did he?
Oh, absolutely not. He consulted for different industries, helped improve lighthouse technology, even investigated pollution in the Thames River. He saw science as this tool to solve real-world problems.
That Thames investigation is really interesting. It seems like a very early example of environmental awareness.
It was. In the 1850s, he wrote this really scathing letter about how awful the river was, comparing it to an open sewer. He was one of the first to really highlight the link between pollution and public health.
He was more than just this brilliant scientist. He was a socially conscious citizen using his knowledge to try to bring attention to critical issues.
Exactly. He believed science had a responsibility to serve society and to improve people's lives.
It's an inspiring legacy for scientists today, isn't it?
Sure.
Sadly, though, even geniuses aren't immune to aging. Faraday's health declined in his later years.
Yeah, it's true. Around 1839, he started having these memory problems and other health issues, probably due to, well, overwork and all that exposure to chemicals in his early research.
It's a reminder that groundbreaking scientific work often comes at a cost.
It does. But even as his health declined, his mind stayed sharp. He continued lecturing, advising others, and remained very involved with his religious community.
He faced those challenges with such grace.
He really did. He never lost his curiosity, his passion for understanding the world.
Okay, so there's this other fascinating aspect of his work that we have to talk about. His research on light and magnetism.
Oh, yeah. This was in the 1840s, and it really stemmed from his conviction that all natural forces were interconnected. He believed there had to be a link between light and electromagnetism.
Building on his earlier work with fields of energy.
Exactly. He thought maybe, just maybe, light is a form of electromagnetic wave.
And this was before James Clerk Maxwell's equations, right? The ones that unified electricity, magnetism, and light.
It was. Faraday's ideas were a real precursor to Maxwell's work. He was on the right path, even without the math, to fully develop the theory.
What kind of experiments was he doing to explore this connection between light and magnetism?
He was working with polarized light, which is light that vibrates in a single plane. And he was passing this light through different materials while applying a strong magnetic field. And in 1845, he saw something incredible. The plane of polarization shifted slightly when he applied that magnetic field.
So he proved that magnetism could directly influence light.
He did. And it's now known as the Faraday effect. It provided more evidence for this deep connection between light and magnetism.
And this work inspired Maxwell to develop those famous equations, showing that light is, in fact, electromagnetic radiation.
Absolutely. It's a great example of how scientific progress comes from this back and forth between those who experiment and those who theorize. They build on each other's work.
And Faraday's work went way beyond just inspiring other scientists. His discoveries led to so many technologies that have shaped our world.
We've talked about the electric motor, the dynamo, but his work also laid the groundwork for radio, television, even modern computing.
It's mind-blowing. It's hard to imagine our world without these technologies. And to think, it all started with a blacksmith's son, driven by this incredible desire to understand the mysteries of nature.
It's a truly inspiring story. And it's about so much more than just scientific achievements. It's about the power of curiosity, perseverance, and the legacy of a life dedicated to, really, the pursuit of truth.
And it's a reminder that even brilliant minds face challenges, right? Faraday had this whole complex relationship with Davy, but he also faced pushback from the scientific community sometimes, too.
Oh, absolutely. Some of his ideas, like the whole concept of fields of energy, were initially met with a lot of skepticism.
Yeah, it must have been tough to challenge those prevailing theories, especially, coming from a humble background like he did.
He wasn't part of the scientific elite, that's for sure. He had to earn his place through sheer hard work and groundbreaking insights. But it's amazing. Even when he was facing doubt, he never strayed from seeking the truth. He let the evidence from his experiments guide him.
He was so meticulous. Those notebooks are incredible. They're a testament to his thoroughness and dedication.
They really are.
And speaking of thoroughness, his work on diamagnetism really shows how relentless he was in pursuing knowledge. He wasn't content with just, labeling substances as magnetic or non-magnetic. He wanted to understand how all materials, every single one, interacted with magnetic fields.
And through these incredibly precise experiments, he discovered that even things we think of as non-magnetic,
Yeah.
they're actually affected by magnetism, just in a different way. Some materials are actually repelled by magnetic fields instead of being attracted. He called these diamagnetic.
It's amazing.
It really is.
It makes you wonder what he could have accomplished with today's technology.
Right. Oh, the possibilities.
Something that really struck me, and I think this ties back to his Sandemanian upbringing, was his incredible humility.
Oh, wow.
He was offered a knighthood, the presidency of the Royal Society, and all these other honors, but he declined them all.
It really says a lot about his character, doesn't it?
Yeah.
He wasn't driven by fame or fortune. He was motivated by this pure love of science, this desire to share knowledge.
And that really shines through in his lectures and writings, too. He was such a pioneer in making science accessible to everyone, breaking down complex ideas for the public through those engaging lectures and, those incredible demonstrations. His influence goes way beyond his specific discoveries. He shaped how we view science, how we think about its role in society.
Absolutely. He highlighted the practical applications, made science relevant to everyday life. He also set this really high bar for integrity and ethical conduct in science, this idea that science should be for the benefit of humanity, not personal gain.
So as we wrap up this deep dive into Michael Faraday, what are the key takeaways? What should we remember about his life and work?
For me, it's important to remember that Faraday's journey wasn't always easy. He faced obstacles, setbacks, you name it. But he persevered. Hard work, determination, and this unshakable belief in himself.
It's a reminder that anyone, regardless of their background, can achieve incredible things if they have the passion and the drive.
Exactly. And Faraday's story is really about the power of curiosity. Never stop questioning, never stop exploring.
And lastly, I think Faraday reminds us that science isn't just about cold, hard facts. It's about wonder. It's about this deep desire to understand our universe.
It can be a source of both profound knowledge and deep inspiration.
That's a great note to end on. Thanks for joining us on this deep dive into the extraordinary life of Michael Faraday. We'll be back soon with another fascinating figure from history. Until then, keep exploring and keep those aha moments coming.